begin with the next session, what we have today. So as I told you yesterday, post IP header will go ahead with the IP addressing because we have been discussing regarding IP. We have been telling that a packet is moving from one router to the other router. It has so and so address, but somehow we are not still aware what an IP address is, what it does, right? So what we'll do today is we'll try to understand what is an IP address, right? And how many classes of IP addresses are there, and maybe that would be the end of today's session. Just a brief about IP addressing, right? So let me present my screen, and I think you can take notes today for IP addressing as it's a little bit important concept. Okay, let's present the screen. So you're able to see the screen, right? Okay. So basically, we've been discussing what an IP address is. I've been telling you that 1.1.1 or you know 2.2.2 something sort of numbers I'm giving you. The dotted decimal format numbers I am telling you since the beginning of the session from the OSI model, right? So these are nothing but these are nothing but called as an IP address, right? So what is an IP address? It's simple. It is just a logical address which is used by the network packets for transferring the data from one router to another router, right? And it generally acts at layer 3, as we are aware, because IP is a network layer protocol. So it acts in the layer 3 of the OSI model, right? So how many variants of IP are there? So there are two variants, two versions, which is IPv4 and IPv6, right? So the reason we have two versions of IPs is that earlier we only had IPv4 during the time when OSI came into picture and when networking was just at the beginning stage when it was starting. So at that time we only had IPv4. At that time only the military and few government organizations had access to internet. So at that time they used to communicate from one location to another location using IP address as we see here. Just the 32-bit format. That's IPv4. But lately we can see that there are n number of users using internet. Each one of us has mobile devices, laptops, smart watches, so everything we have, and we are getting short-handed here with IPv4. So this IPv4 address, what we have currently, is slowly coming to an end. So whatever how much ever IP addresses we have, that is, so total number of IP addresses that we have is 2 to the power of 32. Right? So this value 2 to the power of 32, this value of IP address is what we have. What comes out of 2 to the power of 32? Let's calculate it. So I think it's a big number, 429496 dot dot dot. There is a big number. So those many IP addresses also are slowly at the end. So we are short-handed and out of supply. And looking at that, the researchers created IPv6 address with added little bit of added capabilities, right? So IPv6 address is a 128-bit size which it has, and if you do 2 to the power of 128, you have more number of IPs than what you had in IPv4. and that's the only reason why IPv6 came into picture. And recently, we've been using IPv6. If you have a geo connection at your home, you will see that only IPv6 address is what gets assigned to you on your devices. The reason being geo relies on IPv6 address. And there are some countries like Europe, right, Germany, those countries only have IPv6 support. They do not support IPv4 now because there is no more IPv4 address for them to purchase, right? So that's the short gist of it, why we need IPv4 and what is IPv6. Just a second. Sorry for that. Now let's come one by one to what is IPv4. So we'll go ahead with IPv4. Uh, Now, so what is IPv4? Right. So you can take notes now. I'll dictate. You can take notes. Any queries you can let me know. So IPv4 is nothing but a 32-bit binary number, right? Which is broken into four octets. So what is four octets here? If I told you four octets, but here you only see single numbers here. Now, how these four octets come into picture is an IP address or your computer or any TCP IP stack understands binary. It doesn't understand numbers. It doesn't understand what is 1, 2, 3, 4, 5. It understands 0, 1, 0, 1, 0, 1, 0, 1 or 1, 1, 1 or 0. So that's what it understands. So it assumes that 0 is a no and 1 is a yes, right? If you are into relation sort of a scenario, then otherwise for numbering it uses binaries. So in our current scenario, if it's a binary and in the IP addressing, how it happens is 1111. I'm just giving you an example. How many ones did I write? 1 2 3 4. 1 2 3 4 dot 1 2 3 4. So this is what the computer will understand, right? I'm not converting this value, this binary into number as of now. I'll come to that later, right? But this is how the computer sees this IP address. It will see this could be something else, but still this particular thing will be different for computer. So computer only sees this. If you write a number, it will convert that into binary and it will try to connect to that particular address using binaries only. So that's what computer understands. I believe everybody is aware of this, right? Now, how do you convert a number or an IP address to binary? So it's simple. So what we do generally is you first how it will be done is let me just how do we create this system, right? So okay, let's do this. Two, 16, right. So whenever you try to create whenever you try to create like convert a number into binary, the basic thing what you have to do is you have to convert each and every octet each and every octet into this particular format here, and this you will be able to do like this. So basically how it happens is no, 7. 0. So I told you that each place what we have here, this is divided into each octet, right? So when you divide each octet, everything starts from 0. So 0, 1, 2, 3, 4, 5, 6, 7. And 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, so on and so forth. The values will be until 128. So this is what you'll have to remember. That's it. So once this is done, you you have understood that each and every octet's position is valued from 1 to 128 according to this, right? Once you give it 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, like that, right? Once this is done, now let's go how a number will be converted into an binary. Let's say you have a number 192. Okay, so what will be the binary of 192? So you just have to come from left side. You have to see this value is the greatest value among all these numbers, right? So if you see here 128. So what can you do? You can do 128 plus, then you can add 64 to it. 64. I think that's it. So 128 plus 64 is 192. See? So now, when you get that there are two positions here upon which if we add them, it comes around to the same number what the number we are trying to achieve or get out of it. So that particular value will be 1. So 1 and then 1 and then all the other values will be zeros because we are not using them in that particular number. Now this is the binary for 192. 1 1 0 0 0 0. How many are there? 1 2 3 4 5 6 7 8. So this is the binary for 192. Now similarly, let's say I give you an IP 192.168.0.1, right? Now since we know the binary of 192, we can take this value here, copy it, Control V, and give a dot here. So now we have to find out the binary of 168, right? So how will you do that? Same process, just convert all the bits into the numerical format here, right? Create it like this. And now since we need the value 168, let's go by the same value, that is we start adding up. So for 168, what can you do? 128 plus 32, how much is it? 160, is it? Yeah, that's 160. And then we need 8. So the value will be 1 0 1 0 1 0 0 0, right? So for 192, this is the value, this is what the computer will see, and for 168, this is the value, this is what the computer will see. Now for 0, it remains 0 0 0 0 0, right? Now for 1, it will be simple. For 1, you need not add anything, there is directly one value which we can see here, right? So for that, what you will do is 0 1 2 3 4 5 6 7 and 8. That's it. So now if I write this in the format what we want, that is converting an IP into binary, so this particular IP address will be converted into binary as like this: 116, right? Dot 10101123 dot 0 right? And then we have 1 2 3 4 5 6 8. So this is how you convert an IP address into binary, and this is what the computer will understand. So this is how the computer will like understand, okay, this is 192, this is 168, this is 0, and this is 1, because this is how the computer understands the languages. right? Did everybody understand this?
Yes.
Okay. Any doubts in this? Hello?
Yeah.
No doubts? Okay, then just I'll just write one or two IP addresses. I need answers. I need answers. Just a second. Okay, I'll just provide one or two IP addresses. Just convert them into binaries and let me know answers. I need answers from each one of you. You can put the answers in the chat or you can unmute yourselves and you can type. Right, let me just give you the IP addresses. Let's go with 1.1.1. So that's your first question. Right, next we have, okay. Next we will go with 0.0.1. Okay, and one last question. Right. So let's see. And team, please refrain from using the online tools, the online tools which actually give you the answers or whatever IP addresses I have given. If you have any queries, you can ask me here so that that would be beneficial for you only. Otherwise, you will not be understanding things, how we convert them into binaries. Okay. So now I think we have got two answers. That's correct for the first one. Great job. Now, what about the other questions? Which we,
Third one, for third one, the answer is for 200, the IP, the binary number is 11 100 1 0 0 dot 00 00 00 dot 00 00 dot, and again 000 0 1 0 1 0.
okay.
I'll
Can
keep it.
you repeat or paste it in the chat?
Yeah, yeah, I'll keep it in chat for third one. Yeah, I think Shivakumar already kept in the chat.
Okay, double one zero. Okay. Okay, let's take this as an example. For others who have not yet posted answers, I am assuming that you didn't understand what and how we have to actually convert. Is that right? Right. What we'll do is we'll take this as an example and we'll bring from this binary we'll get the IP address so that you'll understand how this calculation comes about. So let's remove this for now, right? So so this was the first octet, that is 200 here, right? And as I already told you, in order to convert, because IP addresses are in decimal dotted formats of each particular format is an octet, so you will have to get this notation written somewhere when you convert it, when we are doing it manually, right? So here if you see, the number one octet is 1, so that means we considered 128 as number one, right? So 128 plus 64, 64 plus, then which position do we have 1 here? After two zeros, that is 32 is not
Yeah,
there,
it
even is not considered, it's
is
80.
8.
Then this is equals to 200, right? So this is how we get the conversion of it. So it's quite simple. You just have to write this annotation somewhere the moment you get a question for that. And based on the number, you have to decide what's the least number below this. Let's say this is 200. So the least number below this is 128. So keep that aside. So mark it as 1, right? Mark it as 1. And then add the next digit to 128 and see if it is nearing to 200 or not. If you add 120 to 64, it is 192. So yes, it is nearing to 200. Then keep it as 1. Then the next number, if you give this number, if you add to 192, it's going over 200. So that's not going to help us. Then you check with 16. That is also not going to help us. 192 plus 8 is 200. So that's the exact number what you get there. So the next two portions we did not use, you mark it as zeros, and then you give 1 for the portion which you used. And next we do not use 4, 2, and 1. So those also will be zeros, right? So here is the answer you get for converting a number into a binary. So I believe everybody understood this. Now let's see if you can answer this particular question. And I need answers from everyone. So you can refrain keeping the answer in the chat. I'll call out one by one and ask for answers. You can take your time. Let's wait for 2 or 3 minutes. Let's see. You can complete it until 166. That's more than sufficient. Until 166 also is enough. Or you can just give me the value of 166. That's it. What would be the binary of 166? So once everyone is done, you can let me know. I'll
For 166, the binary number is 10 100 110.
what is that? 10.
100 110. 10100 110.
110. So you're adding 128 to 32. That's 160. And then you're adding 4 and 2 to make it a 6. Great. Yeah, this is how it will be. 101 00 110. So this is how it converts. Now, the important thing is how we convert an IP address into binary. That's it. Apart from this, regarding IP, you need not understand things, but if you understand this, that's more than sufficient. Like how we are converting a value into binary. This is a little bit useful in some scenarios, right? So I am assuming that everybody is aware of this now.
Yes.
Great, I got answers from everyone. Nice. Okay, now let's jump to the next section. Now, now the important section is the classes of IP address, right? So based on the IP requirements, how much an organization actually requires, how many IPs that organization actually requires for their purpose. That was a confusing aspect for the researchers at a point of time. When we had this many number of IPs, this particular figure here, this was really difficult for everyone in order to use this range. So if you have an organization with only 10 devices, let's say you own a firm, you own an organization, and in that only 10 machines are there, so you only require 10 IPs. Why would you use these many IPs? That's a waste of resource, right? So in order to avoid that, what they had done is they had divided the IP address into different classes. So there are different classes. So let's see how many classes do we have. So we have A, we have B, we have C, we have D, and we have E, among which the important classes are A, B, and C that we use in our day-to-day life, in our troubleshooting purposes, in organizations, right? And D is used for multicast purpose. We can make a note of it, multicast purpose. So what is multicast? That's the question now. So multicast is nothing but you use the same IP in order to query different other hosts within the network. So you are just, it's like you standing in between and asking the other persons around you, do you have this, do you have that, are you using this IP, are you using that IP, that sort of a thing. So that's called multicasting. So multicasting, let me just give you a small example. Let's say this particular router here, right? And there are n number of routers around this particular router. Now this is an organization. Let's assume this is an organization, and this particular router belongs to the HR department, and this is some department. Let's assume research one department, research two department, research three department, research four, and research five. Right now, this HR wants to send a common email, common information to each and every departments around it which are connected to each other. How he or she will do that, right? For now you will not be understanding a few things, because you might have an opinion that okay, it's simple, right? You will have a logical address. Let's say this particular device has one IP, this has another IP, this has another IP, this has another IP. Just give that particular destination and the job is done. But in our scenario we only have 5 departments. Let's say there are 1,000 departments. What will the HR team do? They will not be inputting from this particular IP, send it to research one, research two, research three, research four, research 1,000. Like that, it cannot keep on sending, right? So that's not the right way, right approach. For that purpose, what we do is we use the class D multicast IP address here. So this HR will send that common data packet to a multicast IP address, 224.x.x.x, so whatever IP address they use within their organization. So when they do that, this packet is automatically sent to each and every router, because that's the multicast IP address. That's how the router understands the language. It does not want to see which particular class of IP address it is, whether I should route it to this particular router or not. That doesn't matter. It just directly uses that using the multicast IP address, because this router is aware that if a multicast IP is given to me, that has to be sent to everybody, right? So it multicast. So what is multicast? In simple terminology, multicast is one to many, right? One to many. And there is another terminology called as broadcast. Now you might hear there are broadcasting radio channels, there are broadcasting TV channels. The TV channel is broadcasting news and all. So what does broadcast mean? Broadcast means one to all. So in multicast, we give one to many. One to many in the sense from that all also we are selecting a few, and that few is called as many. So let's say you have 1,000 departments. Among those 1,000 departments, I want to send email to only 500 users. So what will you do? You will do multicast. What if you want to send it to everyone? You will give a broadcast. Simple. So that's the main core benefit of class D, right? Now coming to class E. So you need not worry about class E. Class E is something which researcher use for themselves to research the requirement for future purpose, how to improve the IP addressing and all. So that's not required for this particular session, and it is not at all relevant for us, right? That is something theoretical and not required at all. So you can ignore this, but you can understand what's the use of the class D. This is a little bit important because you must know what is multicasting, what is broadcasting. That is there. We'll come back to multicast broadcast in the later sessions when we discussed about the routing protocols. So that's different, right? Now, did everybody understand these two classes? Because I will not be coming back to these two classes again. Because we'll be flowing with class A, class B, class C, and then we'll go to subnetting. So we'll not be coming back to this because there is nothing much to discuss apart from this what we just discussed. Are we good?
Yes.
Yes.
Great. Now, so we just discussed about class A, class B, class C, right? So how did they actually divide these classes of IP? Okay. So now, what is a class A IP and how do you actually differ it? Before that, let's jump on to the ranges of these IPs and then we will try to understand. Now, in total, if you see the class A IP is having 0 to 127, but we can write it as 0 to 126. So totally in class A, you are having around 126 number of IPs. So what happens is in class A, 0 and 127 are not considered. The reason being 127 IP it is considered as a loopback IP address. Now the concept of loopback IP address. Right? So what is a loopback IP address? Loopback IP address is nothing but it's a check interface IP address, right? It's a IP address which each and every network interface card is aware of. Let's say you have a new laptop, or maybe you are into manufacturing devices and you want to test whether this particular interface is actually functioning or not. So how will you test it? You ping the loopback IP address of it. You just ping the loopback IP address and then you get a response back. So what is ping? Ping is nothing but you sending two or three or four or hundreds of ICMP packets, right? ICMP is nothing but Internet Control Message Protocol, right? So ICMP port is IP1. So guys, the thing with networking is one topic leads to another, right? So whenever I am trying to tell you class A, I see that we discuss about loopback. From loopback, we are going to ping, and then we go to ICMP, and I tell you that its protocol is IP is equals to 1. So please make a note of this all. This is something important, and with each topic, something additional will be there. and that is what is helpful, right? So ping is a very important concept in networking. So for anything we do ping, right? You do ping for any kind of reachability tests. Let me just show you a small scenario. So let's say you have a URL, you have a website which is not working, it is having some error page on it, right? What will you do? You try you If we think about in a normal scenario, let's say you want to go to a store or you want to go to a hotel for having food, or you want to purchase some item or something, but you are not sure that it is open or not. What do? You call them, right? You call them, you ask them what is the status, is it open, will you be able to serve me food, will I be able to purchase the required items what I want, is it there or not? So you call them. So when you call them, you get a response back. Yes, we are there. And if there is no response or they are not lifting their calls, you assume that okay, this particular location is not open for me. Let's leave that, something like that, right? Similarly, ping also works. It's like you checking if this destination is reachable or not, if this destination is up or not, right? So you check ping reachability. So this terminology is something which you have to make a note of. Destination reachability, right? Ping, ICMP. Okay. Now let me see if I'm able to present this. Okay, great. So I believe you're able to see my command prompt screen now, right? If you see the command prompt screen here, I try to ping www.facebook.com, right? I pinged it. Now you can see I pinged facebook.com. It is trying to go to this particular destination because this is something. Okay, what about DNS? Has DNS been covered? Did, was DNS concept covered? I remember DHCP, SSL handshake, and
Yeah,
DNS.
yes, covered.
DNS is also covered, right? Great. Now you see I tried to ping www.facebook.com, but you can see an IP here. So what happened here? Here is what the concept of DNS comes into picture. So what is happening over here is when you try to ping this, your device doesn't know to which IP address this belongs, right? So your device does a DNS query. So it sends a DNS query to your DNS resolver. Your DNS resolver checks to what particular IP address this FQDN belongs to. Now, if you see here, it is trying to ping star mini.clr.facebook.com, and the IP address is this, right, with 32 bytes of data. So that's different. Now you can see you try to ping this, but it's going to star hyphen mini.cl0 or .facebook.com. Why? The reason being, facebook.com is hosted on the C name star hyphen mini. So I believe if DNS concept is covered for you, there were some important records in that. So host a record, right? The SOA records. So are you aware of that?
No, we don't know about that.
Mhm. So basically, in DNS, we have around 7 important records. If that is not covered, we'll cover it. But among which there is a record known as CNAME record, which means canonical name record. So it is nothing but a alias record. Let's say you want to connect to facebook.com, which you are aware of because you know that facebook.com is a domain which exists, right? But it will go to this particular address because your DNS resolver is telling that www.facebook.com is there. I agree, but it is hosted on this particular destination. Let me check the IP address of this destination, and for this it went to this particular IP address, and that is when it sent a request to this. So these are the ICMP requests and reply which we are getting. So we sent data, we sent packets. So one by one, we sent around 4 packets. You can see here the ping statistics packets. sent is 4 and received is 4, and there is no loss. So the packets were not lost, right? And the approximate round trip timer in milliseconds. So round trip timer in milliseconds is nothing but whenever we send a request packet in the first instance, in how much time did it come back? So that's the round trip timer. So when I send an ping request for this particular IP, I see that within 22 milliseconds it came back, right? And the next packet when I send it came back in 21 milliseconds, and the next 23, and the next 22. On an average, it tells that 22 milliseconds is your round trip timer. Okay, so these concepts we will come one by one, or maybe later when we go to the Wireshark practical sessions and all, we'll come one by one regarding how you can analyze that from the Wireshark packet captures, what actually happens, and regarding DNS, whatever records are missed, we'll cover them in the next session maybe. Okay, so I just wanted to tell you how ICMP basically works. So this is how ICMP works, right? And before that, actually ICMP works in a different way as well. Let me just show you. Yeah. So now, let's say there is one router here, one router here, one router here, and here is the router where facebook.com is hosted. Okay. Now, you are sitting here, I sent a ping request for facebook.com, and I sent it to my own router first. Now my own router doesn't know where facebook.com is, it just knows the address of facebook.com. So what it does, it sends a ICMP request, right? It receives a ICMP request, and then it sends this particular packet to the next router, right, by increasing the TTL value. I told you there is an important concept for TTL in the IP header, and the reason of TTL is this. So ICMP relies on TTL. So once this particular packet, once this particular router receives the packet, whatever this initiator has sent, it knows that there is something called as facebook.com, but it doesn't actually know how to go to that particular destination. So now what it does, if for suppose I'm sending an ICMP packet here with TTL as 1. The reason being I am only telling that, okay, first go to this particular hop and then decide where to go. Then what it does, in first hop it comes here and the TTL expires and becomes 0 here. Now the job of this router is that it has to take the packet to the facebook.com. What it does, it increases the TTL accordingly. If it is aware that after next 2 hops there is facebook.com, then it will increase it to 3, and then it will send the packet here. From here it will flow here, and then it will reach to the destination. If it also doesn't know, it will just keep the TTL as 1 and send the packet to the next router. The next router will do the same thing, it will send it to this, and then it will come here. So that is how that TTL increment is taking your packet to the end and destination host, right? So this is how the TTL concept works, and this is how ICMP actually works, right? Okay, now since we were discussing about class A IP address. So I told you that 127 is reserved for loopback and 0 is reserved for the normal default IP address, 0.0.0.0, right? This particular address is reserved like that, so you will not be using this anywhere. That's the default IP address. Now class A, the range is from, you can make a note of this, class A ranges from 0 to 127, in which 0 and 127 are reserved, 0 being the default IP address and 127.x.x.x, right? So whatever place I tell in an IP address as .x, .x, and .x, that means that any number can come here. 127.1.1.1, that is also a loopback address. 127.0.0.1, that is also loopback address, right? So just remember, whenever after a number and in decimal format I'm telling you write x, that means that any number is coming into that range. right? So this is clear, I believe. Class A ranges from 0 to 127, 127 being the loopback IP address, right? Now, what about class B? So class B IP addresses starts from 128.x.x.x to 191.x.x.x, right? So that's the class B IP address.
He's joined.
Right. Okay. I'm sorry, guys. I had a power cut. Okay. So okay. So where were we? Class B range of IP address, right?
Yes.
Okay. Now, what about class C? So class C ranges from 192 dot x to 223 dot x, right? And then the class D, which ranges from 224 dot x to 254. No, sorry, 239 dot x. Okay, it's 224 to 239. Then what about class E? Class E ranges from 240 to 254. Now there is one broadcast IP which is 255.255.255.255, which is also a class E IP, but it is not considered within that range. But this is the broadcast IP, this one. Okay. Each network has its own broadcast IP. For each network we create, there will be a broadcast IP, there will be a network IP. Right? We'll come back to that point. But these are the ranges what we have got. That is, class A is from 0 to 127, class B is 128 to 191, class C is from 192 to 223, class D is 224 to 239, and class E is 240 to 254, in which 255 and the complete range of 255 is actually the broadcast IP, right? So that's there. Now, okay, so what's the time? Now, I told you about multicasting, I told you about broadcasting. There is a concept called as unicasting as well, right? Which is wherein it works like this, where it only communicates from one router to another. That's it. If there are multiple routers as well, it will not communicate with them. So that kind of communication is called unicasting, right? So, for example, you want to send a ping response to a router within your network. So that is called a unicast, right? But if you want to send information to everybody within the router, within the location, that is called a broadcast. But if you want to send a message to just a few among your organization and not to everyone, then that is called as multicast. Simple. These are the concepts of IP addressing, unicasting, multicasting, and broadcasting. Now, after this, we have an important concept. I believe DHCP is over, right, for you? DHCP is done. Now, in DHCP, in the DORA process, we know that there is a packet that is discover packet, right? And then there is a offer packet, right? And then after the DORA process actually completes, there is a IP address what the end host receives, right? So once the DORA process is actually done, so its job is done, right? What happens? The device gets a IP address. Let's say 192.168.0.1. So whatever DHCP server was there, it sent this particular IP to the device. Let's say there is a DHCP server and there are multiple devices here. Now, in your home also, this particular scenario happens and you can check it today. What you can do is you can enable Wireshark on your machine, right? And then what you can do is you can run a command on your device like this. Just a minute. Yeah, this ipconfig release, right? Once you run this command on your command line interface, it is just going to remove the current assigned IP to your device, right? And then you can run the command ipconfig renew. What this is going to do, it is going to initiate, it is going to initiate the DORA process, right? So when renew comes into picture, you are when you're capturing the packet captures, you can literally see each and every packets in that. You can see the discover packet, you can see the offer packet, and so on and so forth. You can see it until the acknowledgement packet. You can see everything. And if by chance, let's assume your DHCP server here has the capacity of only 10 IP addresses, right? And there are about 11 devices within your home network. Let's assume, just as an example, this scenario is not there, but let's assume that there are only 10 IP addresses which this DHCP server can provide, right? Now, there are only 11 devices within your home network. When there are 11 devices and you have got everything assigned, your devices, your all other devices have IP addresses assigned. Let's say from 192.168.0.1 to 0.9, all the IP addresses these equals to 10 IP addresses are assigned. Now we need another one IP, right? But that is not there. Then what is the status of that device? What IP address will that device be on? So it cannot be on 0.0.0.0 because you know that 0.0.0 is a default IP address under class A. So that cannot come here. So what IP address will this machine be assigned with? Any idea? Okay. So it will be assigned with this particular IP address 169.254.x.x. That means any number can come here until 255. So the maximum number what can come here it is not 255, 254, right? So the maximum it can go until 255 or 254, right? Now this 169.254.x.x, this value is called as APIPA. So in normal scenario in the offices or in the organizations when you troubleshoot an issue, APIPA IP address comes into picture, and the moment APIPA IP address comes into picture, you must understand that that particular device doesn't have an internet connection at all, or the DHCP server, whatever was trying to send the IP addresses, it is not assigning the IP address to this device. Simple. So what is APIPA? So APIPA is nothing but automatic IP address configuration, right? So it automatically assigns a IP to itself, and this IP address is a known IP. By design, it is a known IP to everybody. So if 169.254.x.x any number is here, then that means that that device doesn't have internet connection, and that device is going to APIPA, right? So that IP address comes by default from the TCP IP stack. Okay? There is no like difference between any OS. For example, if it's a Linux OS, if it's a Mac OS, or if it's a Windows OS, it is going to stay on this IP until and unless it gets a IP address assigned, right? The moment the DORA process completes, in the meantime, your device stays on this. The moment it completes, the DORA process completes, it will get assigned a IP address 192.168.0.1 something, whatever it is, right? Whatever your DHCP is configured with. So your DHCP's job is to give you IP address, right? It's like your locality or your local government trying to give you a address for your location. So you get yourself registered, right? You get yourself registered into voter IDs or Aadhaar cards, mentioning that my address is so and so, your address is so and so, like that. So in the similar fashion, all the devices shall have the logical address assigned to them in order to communicate via internet. And that logical addressing is called as IP address, which is nothing but the 32-bit format, which is denoted in dotted decimal formats into octets. So each octet, right? Each number is an octet. Okay, so that is what DHCP does. Its job is to provide you an IP address. And if in case your machine doesn't have a IP address assigned, it should have the APIPA IP address there. And this is the reason why you should remember this IP address 169.254. This is very important when you troubleshoot any scenario. If for a device you see a IP address as 169.254, you can straight away tell to the user that go and check with your DHCP team. The issue seems to be with your DHCP team, not with whatever product I am working on, right? So that's how you troubleshoot issues. At your home also, sometimes you might not get internet. Go ahead, check what is the IP address your device is on. Log into the router in your home. Check what all things are there within that router. What IP is assigned to which particular MAC address. So post this concept, I'll come back to the layer 2. In that, we will be discussing about different other protocols like ARP, right? MAC address binding, right? And what is actually the MAC address. So these concepts will cover later on. But as of now, I hope everybody is clear with what we have discussed today. So that is what is IP address, right? How many versions are there? Okay. How do we convert IP address into binary? And then the classes of IP addresses A, B, C, D, and E. D being the multicast purpose, right? And A, B, C, we use it in our day-to-day life. So these are very important. And these importance you will understand when you learn subnetting. So subnetting, I'll try to cover it next session. If I start subnetting now, it will be confusing. But I hope everybody is aware now, understood the basic until now regarding IPs, the ping, multicasting, broadcasting. I know we have covered a lot today. I hope everybody has taken single side notes at least. At least take single side notes, whatever you see new, as I told you in the initial class. If I tell something new, just make a note of it. Try to research on it, create your own notes, and if you have any queries, let me know. So, has everybody taken it? Everybody is aware what we have done today?
Yes, we are taking the notes also.
Great.
Yes.
Great. So, whatever concept is remaining, so I think DNS, we need to understand the 7 records, and was practical thing also taken on that, like how the domain name system is actually resolving the queries and all, Wireshark packet capture. Okay, no problem. I'll just show that in the next session. And regarding DHCP, DNS, and all, there are sample packet captures which are available for free online. So you can go ahead and do a Google search as well. For DHCP, you can search. For DNS, you can search. So these packet captures, I'll try to gather them and I'll show in the next session whenever we have time. Today, I think we already crossed the limit. Not a problem. I think we have covered a lot, and you have 2 more days to just revise whatever we have done since the past 2 weeks. Any queries? Let us know on Monday. We'll start. We'll go in depth from class A, class B, class C, and then we'll jump into subnetting. So there are a little bit concepts remaining here in the IP addressing. That is the difference of IPv4 and IPv6, and then we'll go to the subnetting. Right. So I believe everybody is okay as of now. I think we'll wind up the session now. Happy weekend, guys.